Welcome back to a new data science project. In this video, we are going to predict the insurance payments using machine learning. We are going to do data analysis and we are going to train machine learning models. And at the end, we are going to create a Streamlit web app for deploying our machine learning model. You can see the final version of the app that we are going to be creating in this video from the screen right now. Also, I'm going to be sharing the datasets link in the description of this video. You can download the dataset from that link. Let's start coding. Okay, here's the dataset link. It's the dataset that we are going to be using in this video, and I uploaded it to GitHub. So how you can download this data file is you can click the file from here. I'm going to leave this link in the description. You just need to follow that link, and after that you need to click the file, and next you are going to see at the right top you will have more file actions section, and from here you are just going to click on this and you are going to say download, and you are going to be able to download the CSV file after clicking on this button. In this way, you are going to be able to run the codes on the same dataset that I'm going to be showing in this video. Okay, let's take a quick look to our dataset, and then we are going to continue on the VS Code. So we have ID, age, gender, BMI, blood pressure, diabetic, children, smoker, region, and claim. Columns, which claim is going to be our target value. In this video, we are going to be trying to predict the values of the claim based on the features in here. And also I can see that we have missing values in our dataset. We need to clean those, and we have both categorical and numeric data in our dataset, and everything seems great. Okay, now I'm going to be re-recording in the VS Code. Again, you can find this link in the description of this video for downloading the dataset. Okay, I'm in the VS Code, but you can use any code editor that you want. And at the start, I'm going to create a Jupyter notebook. We are going to do the data analysis, feature engineering, and the training machine learning model sections in a Jupyter notebook. And for the Streamlit app, we are going to create a Python file. So I'm going to say analysis and model IPMB, and in my Jupyter notebook, I'm going to select my kernel. It doesn't really matter if you have something greater than 3.5. And I'm going to start by the imports. So I will say import pandas as PD, import matplotlib pyplot as plt, and import seaborn as SNS. And next I will go to the Explorer, and on the dataset I will right click and say copy relative path, and then I will say data frame, and it's going to be equal to the pandas with CSV, and I'm going to paste its name in here. So we can check if it's successfully loaded or not by just calling data frame. It's going to display the first 5 and last 5 rows like this with the row count and column count, and everything seems good. And what else we can do is we can just say head for seeing only the 5 rows. It's defaultly 5, but if you specify like 3, you are going to see the first 3 rows. You can also call the tail for seeing the last 3 rows, for seeing if data is loaded successfully. Okay, so next I want to get the general information of my data. So I'm going to call the information method like this, and we are going to see that we have a data frame with range index 1340 with their data types. From here we can see that we have like 5 null values and 3 null values on the region. Okay, we have 3 floats, 3 integers, and 4 objects. Also we can see the memory usage from here, and we can also see the row and column count information from here. Like we have 10 columns with 1340 rows. Okay, I want to start by doing a setup for the pandas and seaborn. So I will say PD set option. I will say display float format, and I'm going to say I want to format the float data type like this, and I will use that format after that. So when I call the data frame, you are going to see that we have only 2 decimal points for the floats. It wasn't like this when we first run the data frame. Okay, I will also do a similar thing for the seaborn plots. So I will say seaborn set, I will say style, and it's going to be white grid, and I will say palette. I want to set my palette as set to, and I'm going to say font scale is going to be 1.1, and I'm going to make it run like this. Okay, now I want to start by checking if we have any duplicated values. So when we call data frame duplicated, it returns true and false boolean values row wise. And if we say sum, we are going to see that if we have any, we don't have any duplicated values. Awesome. Let's check the NA ones. So I will say data frame is NA, and it's going to return me boolean cell wise. If I say sum, it's going to give me the NA value count row wise. And if I say sum again, I'm sorry, I meant column wise. Like with the first sum, we can see the column wise NA counts. With the second sum, we can see the grand total. And since these are really small numbers, we are not going to be losing a lot of information if we just drop them. So I'm just going to drop those. So I will say data frame drop NA, and I'm going to say in place equals to true. So in this way, we are going to have a new data frame shape of 1332 instead of 1340. We dropped 8 rows. Okay. Now we can quickly check if we have any NA values again with sum again, and we have 0 right now. Okay, let's continue with the summary statistics. If you say data frame describe, you are going to see that you will have the numerical column summaries like this. But if you pass include all inside of this, you are going to see that you will also have the categorical column summaries. Like, let me cut that in here. I will show you. In the numerical side, we will have count, mean, standard deviation, minimum, 25, 50, 75 percentiles, and maximum value. But if we say include all, we will have unique, top, frequency, and much more like this. So let's quickly check the numerical ones, and then we can check the categorical ones. In here, the average age is 38, and we have the minimum age of 18 and we have the maximum age of 16. On the BMI side, the average is 30 and minimum is 16, maximum is 53. On the claim side, we have the average of 13,000 and minimum of 1,121 and the maximum of 63,770. Okay, now I will say include all, and let's check the categorical columns. On the smoker side, we have 2 unique values, yes and no, and the top occurring value is no with 1058 in 1332, so we have around 280 yes values. And on the region side, the top appearing value is southeast, and on the gender side, the top appearing value is male with 670. I think we have around 662 female entries, and okay, awesome. On the diabetic side, we have 2 unique values. No is the most appearing with 695. We have 650 around of yes values inside the data we have. Okay, awesome. Let's continue. Now let's see the distributions of these columns. I'm going to start with numerical columns, and these are age, BMI, blood pressure, children, and the claim, like this. And in here, what I'm going to say is I will say data frame, numeric columns, dot histogram. I will set the bins as 20, and let's set the figure size like 12 to 8, and I want to set a color like sky blue, and I'm going to set a edge color like black. Next up, what I'm going to do is I will say PLT subtitle, and I will say distribution of numerical features, and I will say font size, and it's going to be 16, and I will say PLT dot show at the end. So we are going to have something like this. So in here we can see that the age is well distributed around 2060. We have entries in all ages. On the BMI side, it looks like normal distribution. It's similar to normal distribution. On the blood pressure side, we have more values at the lower end, like at the 80 to 100 side. On the children, we have the most values at the no children and 1 children side. And on the claim side, we have the most values in the lower end of our histogram. Okay, now let's see the categorical distributions. So for that I will say categorical columns, and it's going to be gender, diabetic, smoker, and region. And in here I will say PLT figure, and I'm going to set it like the same. And next I will say for index and column in enumerate categorical columns, this one, and I will say 1. I will say PLT subplot 2, 2, and I. Next up I will say seaborn count plot. I will pass data, data frame, and X is going to be the column. And I will say PLT title, and we are going to use an F string in here, so we can say like distribution of the column. We can pass the column dynamically inside with the help of F string. And I will say after this PLT title layout, and I will use plt.show. So we are going to have something like this. Awesome. So one by one we can see that the values are similar on the gender side, and on the diabetic side we have no as the leading option, and on the smoker side no is just at like 1000 and yes is just around 200, and on the region side we have the southeast as leader for our dataset entries. Okay, let's continue with exploring how claim varies with key factors like gender, smoker, region, and children. So for that I will say data frame group by, and I'm going to do multi-index group by, so I will say gender and smoker, and I will say claim dot mean, and also what else we can say in here is around 2, like this. And we can see that before talking about genders, we can easily say that if someone is smoker, their insurance payment is higher, which is a thing that we can expect for sure. And on the non-smoker side, male has a lower insurance payment, female has a higher insurance payment. Okay, we can create a visualization from that, like seaborn bar plot, data will be data frame, and also let's make it bigger. So I will say PLT figure, I will say figure size 8 and 5, X is going to be gender, Y is going to be claim, and hue is going to be smoker, and estimator is going to be mean, and we will set the error bar as ST. And next up what I'm going to say is I will say title is going to be average insurance claim by gender and smoking status. And after that we can say plt.show. So here we are going to have something like this. It's the information that we talked about in here. Like if someone is smoker, then they are going to be paying more insurance. Okay, now let's check the average claim by region and diabetic status. So I will say pivot region diabetic, and it's going to be data frame group by, I will say region diabetic, and I will say claim, and I will say mean, and on stack. So we are going to have something like this in here right now. And what we can do in here is we can say pivot region diabetic dot plot, we can set the kind as bar, and we can say figure size 8 and 5, a big plot again, title average claim by region and diabetic status, and Y label is going to be mean claim. Let's see the plot we will have right now. Yeah, here it is. Without considering the region, we can say that diabetic is not really effective on the insurance payment. And on the average claim side, we can see that Northeast is the leader in terms of average amount. Okay, now let's see the average claim by smoker and region. So I will say pivot table, and it's going to be PD pivot table. I will pass data frame, values, claim, and index is going to be region. Columns are going to be smoker, like this, and aggregation function is going to be mean. So we can directly call pivot table. We can see how the values increases if someone is a smoker. Okay, let's see the average claim by diabetic and children count. For that, I will say pivot table again, and it's going to be pandas, pivot table, data frame, values are going to be claim, and index will be children, columns are going to be diabetic, and aggregation function is going to be mean again. And I'm going to call the pivot table like this. It seems like with the children count 2, the claim is at its highest. Okay, now let's do a correlation heat map. So I'm going to call the numerical columns list again. Yeah, great, we have that. So I will say figure, and I will pass figure size of 8 and a 6 this time, and I will say seaborne heat map. I'm going to pass the data frame numeric columns. Like, let me quickly show you. When we pass that, we are going to have something like this in the heat map. So in here, after that, I will say not true, and color map is going to be, let's do cool warm, and I'm going to format it like 2 decimals. And next I will say title correlation heat map, and I will use plt.show in here. And after it calculates the correlation, actually I forgot to put the correlation in here. So now we need to have, the correlation heat map. So let me quickly show you. When we call correlation like this, we have a table like it, and we just turned it into a heat map. Okay. It seems like on the numerical columns, only blood pressure is a little bit correlated with claim, and the others are not really correlated, not positively or negatively, because we don't have any values closer to 1 or -1 in here. Okay, now let's continue with some relationship analysis, and I want to first start by claim and age. So I will say seaborne scatter plot, and I'm going to pass data is going to be data frame, X is going to be age, Y is going to be claim, and hue is going to be smoker. And after that I will say style is going to be gender, and I'm going to set the alpha like 0.7. Next up I'm going to say title and claim versus age by smoker and gender, and I will say plt.show in here. Here we don't really see a gender-based difference, but we can see the smoker difference for all ages. Like if someone is smoker, they are paying higher insurance payment, and otherwise we don't really have a big difference for the other values. Now let's check the BMI and claim. So I will say seaborne regression plot, and data will be data frame, X will be BMI, Y will be claim, and let's say scatter keyword arguments, and we are going to pass alpha as 0.6 in here. Next up I will say plt.title, and I will say relationship between BMI and claim amount, and I will say plt.show after that. So we are going to have something like this. And as we can expect, like the general trend is, when BMI increases, the insurance payment increases too. Now let's check the children and claim. So for that I'm going to use a box plot, and I will pass the data as data frame, X as children, Y as claim, and also at the end, let's just keep it like this. I don't want to add a hue to this, and I will say claim distribution by number of children, and I will say plt.show. So we are going to have something like this. Yeah, as we previously talked on a chart, at the children count of 2 or 3 we have the highest insurance claim if we want to generalize. Okay, awesome. Okay, now instead of treating age as continuous, let's create age bands and see claim patterns. So I will say data frame age group. It's going to be a new column and it's going to be pandas cut data frame age, and I'm going to give the bins like 0, 18, 30, 45 and 60. And next up, what I'm going to say is, let's say 102, and labels are going to be less than 18, 18 to 30, 31 to 45, 46 to 60, and 60 plus. So I'm just going to call the data frame again and show you the new column we have. Here we have the age group as categorical column, and we can call data frame age group dot value counts, and we will see that we have the categories that we can visualize right now. And let's create a bar plot with this information. So I will say seaborn bar plot. I will pass the data as data frame, X as age group, Y as claim, and I'm going to say estimator will be mean, and error bar is going to be standard like this. And I will say PLT title average claim by age group, and let's see our plot. Here it is. Okay, here we can see that the age group of 80 to 30 has the highest amount of average claim. Okay, now let's classify BMI into World Health Organization categories and compare the average claims. So we are going to use pandas cut again. I will say data frame BMI category, and I will use PD cut. It's going to be data frame BMI, and we will say bins are going to be, let me check the values from the internet, 0, 18.5, 24.9, 29.9, and we are going to say 100 for the other, because others are classified as obese. And we will say labels. Now we have underweight, we have normal, we have overweight, and we have the obese, like this. And here we can get the value counts. The most of the values in our data frame is classified as obese. Okay, let's see it in a box plot with the data X as BMI category and Y as claim, like this. And hue, let's add the hue like smoker, and I will say PLT title claim distribution by BMI category and smoking status, and I will use plt.show. Here we can see that if someone is obese and have the smoker option as yes, it has the highest average claim amount as we can expect. And here without the smoker information, like let me just delete those, and let's see without the smoker option from here like this. And actually I also need to add this. Also I'm going to say import warnings, and warnings filter warnings ignore because I don't want to see any of those again. Here we had underweight option as the lowest average value of claim and highest at the obese. Okay, now let's do a final analysis, then we are going to move into feature engineering. I want to see the smoker rate and claim ratio by region. So I will start by saying region stats, and it's going to be data frame group by, and in here I'm going to group by region, and I'm going to say aggregate, and in the aggregation function I will say smoker rate is going to be smoker, and I will say lambda x equals to yes dot mean, and next I will say it's multiplied by 100 like this, and I will say mean claim is going to be claim and mean, and after that I will say reset index. So we are going to have something like this in here. And for making this information visual, I will say figure. X1 is going to be PLT subplots, and I will pass figure size of 8 and 5 like this, and I will say bar plot, and data will be region stats, X will be region, and Y will be smoker rate. And for the X side, I will say X1, and alpha is going to be 0.6. Next up, I will say X2 is going to be X1.twin X, and next I will say seaborn line plot. I will say data will be region stats, X will be region, but this time Y will be mean claim. And after that, I will say X accused X2 color will be red, and the marker is going to be all like this. And after that, I will say X1 set Y label smoker rate, and set Y label average claim, and we can add like dollar sign in here. Next up, I will say title, and it's going to be smoker rate and average claim by region, and I will say plt.show like this. Okay, at the left axis we can see the smoker rates at the percentage, and at the right side we can see the average claims, and at the smoker rate Northeast is the leader, and at average claim we already know that Northwest is the least value. Okay, now we are going to start preparing our data for modeling. And at the first place, let's start with our imports. So I will say from scikit-learn model selection, we will import train test split for splitting our data into training and testing sets. And I will say from scikit-learn preprocessing import, we will use label encoder for the categorical columns, and we are going to use standard scaler for scaling our data. And I will also import joblib because we are going to export both the encoders and the scalars, and we are going to be using the same scaler and the label encoder that we use in this notebook in the Streamlit app. So we are just going to save them as pickle files, and in the Streamlit app we are going to load them back and use them again. So let me call the data frame firstly, and in here what we are going to do is, actually the columns will be more than enough. In here we are going to select the X, like let's say data frame, I want to use age, gender, BMI, blood pressure, diabetics, and next I want to use the children and also smoker. I'm not going to take the region. And for the Y, I will take data frame claim, just like it. Okay. Next, I want to encode the categorical features. Like in here, we need to do that for gender, diabetic, and smoker. For that, I will say categorical columns, and I'm going to set them like gender, diabetic, and smoker. And I will say label encoders, and it's going to be an empty dictionary just for now. And in here, I'm going to say for column, in categorical columns, we are going to iterate over this list. I will initialize the label encoder inside the loop, and I will say X column is going to be label encoder fit transform X column like this, actually the capital letter X. Next up, I will say label encoders, the empty dictionary that we defined in here. I will pass the column, and I will say LE, the thing that we initialized in here. Next up, I'm going to say joblib.dump label encoder, and I'm going to use an F string like label encoder, and I will pass the column name dot pickle like this. So when I make it work, just when I run the cell, you are going to see that We don't have like any type of pickle file in here, and I'm going to make it run. Now it's going to put the pickle files in here so we can load them back in our Streamlit app. And let me quickly call the X again. We are going to see that for gender, diabetic and smoker we have the numeric values right now instead of categorical ones. And at the label encoder side we are going to have the gender, diabetic and smoker like this. Awesome. Now we are going to split our data into training and testing sets. So I will say xtrain, xtest, ytrain and ytest, and it's going to be train test split. I will pass x, y and test size of 0.2, which means that 20% of the data is going to be in the testing set and 80% of the data is going to be in the training set. And we are doing this operation before the scaling because we are only going to do fit transform of our scalar in the training set because we don't want data leakage. Okay, now we are going to scale the numerical features. So let's say numerical columns, and they are going to be age, BMI, blood pressure and children. And it's going to be scalar, standard scalar. We will say xtrain, numerical columns, and we will say scalar, fit transform, xtrain, and I will pass the numerical columns. Next, I will say xtest, numerical columns, scalar, transform, xtest, numerical columns, just like this. Again, we are only using the fit transform for the training set and we only use the transform for the test set. Also in our Streamlit app, we are only going to use transform for the user input. Now we need to save the scalar. So I will say joblib.dump scalar and I'm going to export it as scalar.pickle. So when I run this, we are going to see that we are going to have scalar.pickle in here. Awesome. And we can see like the training set shape and test set shape like print xtrain.shape and ytrain.shape, and we can say print xtest.shape and ytest.shape like this. Okay, here we can see that 20% of the data is on the test set. Now we are going to train machine learning models, but in here I'm going to do something different. We are going to do parameter tuning for all the models and we are going to create a comparison table at the end. On our other projects we go one by one, but in this project I'm going to train all the models in one cell and only going to talk about the results in a comparison table. And also I'm going to pick the best model programmatically and I'm going to export that model using only codes, not by typing the model's name. So you can use the same codes for any data set that you want to train machine learning models on, and you can just pick the best performing with the same codes for any data set. And the algorithms that we are going to be using are going to be the linear regression, polynomial regression, random forest regressor, support vector regressor, and XGBoost regressor. Okay, let's do that. Firstly, I'm going to do the imports like numpy as MP. We will say from scikit-learn linear model import linear regression. We will say from scikit-learn.preprocessing import polynomial features. From scikit-learn.ensemble import random forest regressor. From scikit-learn svm import svr support vector regressor. And from scikit-learn model selection grid search for parameter tuning and the cross-validation score. And we will say from scikit-learn.metrics import mean absolute error, mean squared error, and also I want to use r-squared score. And I will say from XGBoost import XGBoost regressor like this. These are going to be our imports. And again, you are going to be able to use the same codes for any kind of regression model. That's my goal on these codes. So for any regression problem, we are going to say define evaluate model, and in here our function is going to take model the training and testing set like X test, Y train and Y test, and nothing else. And in here we are going to say Y prediction, and in here we are going to make predictions with the model that we trained. And next up we are going to take the R-squared score using Y test and the test set with the predicted values we have, and on the mean absolute error side we will say mean absolute error, and we will take the test set by values and the predicted values. And for the root mean squared error we will say numpy square root, and we will say mean squared error with the Y test and Y predictions. So we only need to return those right now. Return, and I will say R squared is going to be R squared, mean absolute error is going to be mean absolute error, root mean squared error is going to be root mean squared error. And let me quickly summarize this code for you. Here we define a function with the inputs model, X train, X test, Y train and Y test. Actually in this case the training sets are not really necessary inside this function, but if you just want to extend this to something like model training and evaluating pipeline, then you are going to need it. So I just want to include those on E here too, and we get predictions from the model that we trained outside of this function, and we get the predictions based off the test set we have on the features that we have on X, and we store them into Y predictions. Next up we take the R squared score, mean absolute error, and square root of the mean squared error using the metrics we initialized from the scikit-learn, and we return those in a dictionary like the R squared score for the model that we call mean absolute error and root mean squared error. And next up we are going to define a dictionary to store the results, like results are going to be on a dictionary like this. And now let's start coding our model training codes. So linear regression, we are going to initialize the linear regression like this, and then we will say linear regression.fit. We will pass the X train and Y train, and we will say results, and I'm going to say like in here linear regression, and on here we are going to call the evaluate model. We will pass linear regression, X train, X test, Y train and Y test in this order, and then we can say print linear regression model trained. So it is ready. It's this easy. We are not going to be doing any kind of parameter tuning on a linear regression, but others are going to be a little bit more complicated than this. Okay, let's continue with polynomial regression. So we are going to try the polynomial degrees of 2 and 3. Let's start. I'm going to say best polynomial model. It's going to be none for now, and we will say best polynomial score is going to be infinite like this, and we will say for degree in 2 and 3, poly is going to be polynomial features. We are going to say degree is going to be equal to degree in the for loop that we iterate of, and we will say X train polynomial is going to be polynomial fit transform X train, and X test polynomial is going to be polynomial transform X test. Next up we are going to say polynomial linear regression is going to be linear regression like this, and polynomial linear regression dot fit, we will pass X train polynomial and Y train. Next up we will say score is going to be equal to the polynomial linear regression dot score X test polynomial and Y test. So after that what we are going to do is if score is greater than best polynomial score, which we defined in here, and also for the first try it's going to be 100% greater than it, so it's going to work out smoothly. We will say best polynomial score is going to be score, and best polynomial model is going to be degree polynomial and polynomial linear regression like this. and this is going to be our loop for training with different polynomial features, and we will say degree polynomial and polynomial linear regression is going to be equal to the best polynomial model. So we are going to define those like this, and we are going to say results, and in here we are going to save it like polynomial regression. Like I will say degree is going to be degree like this. We are going to be passing it dynamically with the help of the f strings, and it's going to be, we are going to call the evaluate model, and we are going to give polynomial linear regression, polynomial fit transform xtrain, and we are going to say polynomial transform xtest. We are going to give ytrain and ytest like this. Awesome. So we will say print polynomial regression models are trained, and these are going to be our codes for training a polynomial regression. Awesome. Now we are going to continue with the random forest regression. So for that we are going to use grid search on the parameter tuning side, and I'm going to initialize it like random forest regression directly. And next up I will say random forest parameters are going to be, we are going to give number of estimators like 100 and 200. Next up I will say max depth none, 10 and 20, and I will say minimum sample split is going to be taking values 2 and 5, and I will say minimum samples leaf are going to be taking values of 1 and 2. And we are going to initialize the grid search on random forest grid, and I will say grid search cross validation random forest parameters like this. Cross validation I'm going to set as 3, and scoring is going to be r squared, and also I will say number of jobs -1, and I'm going to set the variables as 0. I don't want to see logs on this. Okay, and I will say random forest grid dot fit. I'm going to fit it on the training set like this. Next up I'm going to set the best random forest using random forest grid best estimator like this, and let's set this to results like random forest, and we are going to call the function that we defined best random forest xtrain xtest ytrain and ytest like this. And for the grid search ones we can just call the best parameters like I will say print random forest training is completed best parameters, and we can say like random forest grid best parameters like this, and also I will add this in here. Okay, random forest is completed. Now we are going to do support vector regression. So we need to say SVR, and it's going to be equal to the SVR. We are going to initialize it like this, and let's define its parameters like SVR parameters. We have kernel, which can take values like RBF, polynomial or linear, and I will say C, and 1, 10, 100 can be possible values, or maybe let's just say 50, and I will say epsilon, and it's going to be 0.1, 0.2 and 0.5. Next up I will say degree, and it can take values like 2 or 3. Okay, now I will say SVR grid, and it's going to be grid search cross validation SVR parameters cross validation 3, and scoring is going to be r squared again, and I will say number of jobs will be -1, and I don't want to see any logs, so I will say this. And next up I will say results support vector regression, and it's going to be evaluate model. I will say best support vector regression, and let's define it like I will say SVR grid fit xtrain and ytrain, And after training the model, I will say best SVR is going to be SVR grid, best estimator like this. And let's continue on this side right now. I will say xtrain, xtest, ytrain, and ytest in here. So after that we can say like print support, let's say SVR training is completed, and we can say best parameters, and these are going to be best. Let's not go from that. I will say grid, and I will select the SVR grid, and I will call the best parameters. Okay, awesome. We only have XGBoost left. Let's also quickly complete it. So I will say XGBoost, and it's going to be XGBoost regressor. Objective is going to be regression, squared error. And let's define the parameters. Like XGBoost, parameters are going to be number of estimators. Let's give values like 100 and 200. And max depth, let's give values like 3, 5, and 7. And I will say learning rate, and I will say 0.01, 0.05, and 0.1. And after that I will say subsample, and let's give values like 0.8 and 1.0. Next up, let's initialize the grid search like XGBoost grid search cross validation, XGBoost parameters. Let's set the cross validation as 3 and scoring as R squared. And next up I will say number of jobs -1 again, and verbose 0 like this. And next I will say XGBoost grid dot fit xtrain and ytrain, and I will say best XGBoost is going to be XGBoost grid best estimator, and we are going to say results, and it's going to be the final XGBoost, and I will call the evaluate model on best XGBoost, and also the xtrain, xtest, ytrain, and ytest. And also we can say like XGBoost training is completed, best parameters. And we can say XGBoost grid best parameters like this. And here our model training codes are completed. Let's go one by one. We have the linear regression, we have the polynomial regression in here with the options 2 and 3. You can extend this list, also the parameters, it's up to you. We have the random forest regressor, we have the support vector regressor, and the XGBoost. So I'm just going to make this cell run, and we are going to see that linear regression model trained, polynomial regression models are trained, random forest training is completed. We have the best parameters of max depth 10, minimum samples leave 2, minimum samples split 5, and number of estimators 200 in here. And on the support vector regressor side, we have the best parameters of C50, degree 2, epsilon 0.1, and kernel linear. And for the XGBoost, we have the best parameters of 0.05 on the learning rate side, 3 on the maximum depth, 100 on the number of estimators, and 1 on the subsample. Now it's time for comparing the results. So let me quickly call the results. Now it looks like this, but I'm going to make it look better. So for that I will say results, data frame is going to be pandas, data frame, results, and I will use .t, and I will use sort values. I'm going to sort it by R squared like this, and I will say ascending equals to false. So after that I will say results data frame, and we are going to see that we have the models, their R squared values, mean absolute errors, and root mean squared errors. In here, random forest is the winner model for this dataset, but again you can use this code for all of the regression problems. You can train these 5 models and find the best one suits to your data using the same code. You can also extend these parameters. Okay, it seems like we have equal R squared values on the random forest and XGBoost, but if we just check from this display we have a higher value on the random forest compared to the XGBoost. Okay. Also we can see that the second degree is selected for the polynomial regression. Okay. Now let's take the best model as a prediction model for the Streamlit web app. But as I said, I'm not going to do this. Like I can directly call best random forest and export it with joblib, but I'm not going to do that. What I'm going to do is I'm going to take it out from this Jupyter Notebook programmatically, so you can run the same code, and if this table changes for your different dataset, you can only use this code for exporting the best performing one. So let's say models, and these are going to be linear regression, and polynomial regression, and it's going to be polynomial linear regression, random forest, and it's the best random forest. We are going to say support vector regressor, it's the best support vector regressor, and XGBoost, it's going to be the best XGBoost. So actually we need like two dots like this. Okay, now what we are going to do is we are going to find the best R squared. So best R squared is going to be results data frame R squared that maximum. And next, let's check the best R squared. Here it is. So we will say top model is going to be results data frame R squared equals to best R squared. So the top model is going to be a random forest like this. We can filter it out programmatically like this. If this was XGBoost was going to come. If this was linear regression, we will have linear regression in here. So we will say best model is going to be models, and in here we will say top model, and we will say index, and we will say 0. So the best model is going to be random forest regressor like this. Now I'm going to say joblib.dump. I will pass the best model, and I will save it like best model.pickle. And now we can call, like we can say print f string best model selected, and we can say best model, not the best model, we will say top model index 0 like this. Here we can see that it says best model selected random forest with the tuned parameters it has, and we have it on the print statement. So we will have best model.pickle in here like this. Now we are ready to create our Streamlit app. I'm just going to say my Jupyter Notebook, and here we did data analysis, we did data preprocessing, and we trained machine learning models. Now we can continue with the Streamlit app. So I will say app.py, and I'm going to continue from a Python file like this. And in here we are going to start by importing Streamlit. Then we will import pandas, we will import numpy, and we are going to import joblib. And these are going to be enough. So let's start by loading the saved objects like we saved in here. I'm just going to keep this Explorer open. So what I'm going to do is I will say scalar is going to be joblib.load, and I'm going to say scalar.pickle. Next up, I will say label encoder gender, it's going to be equal to the joblib.load, and I will say label encoder gender.pickle. And after that, we are going to say label encoder diabetic, and it's going to be joblib.load, and we will say label encoder diabetic.pickle. And next we are going to say label encoder smoker, it's going to be joblib.load label encoder smoker.pickle like this. And after that we are going to say model, and it's going to be equal to joblib load best model.pickle. And I'm going to quickly check if you have any typo or something like that. Label encoder smoker, gender, diabetic. So I'm just going to close the Explorer, and let's start building our Streamlit app. For the UI, I will say Streamlit set page config, and in here I'm going to give the page title like insurance claim predictor. And next I will say like layout is going to be centered. Next up I'm going to say Streamlit title and health insurance payment prediction app, and I will say Streamlit write enter the details below to estimate your insurance payment amount like this. Okay, awesome. Now we are going to create a user input form. For taking the inputs, I'm going to use streamlit.form. So I will say with streamlit.form input form, I'm going to say column 1 and column 2 is going to be Streamlit columns, and we are going to add 2 columns. With column 1 we will say age is going to be Streamlit number input age, and like this. Minimum value is going to be 0, maximum value like let's say 100, and the default value is going to be 30. And for the BMI, I'm going to say Streamlit number input BMI. Let's set the minimum value as 10, maximum value is something like 60, and value as 25. And also I want to display them as floats, so I'm going to say 25.0.0 and 10.0 like this. And next up I will say children, and it's going to be Streamlit number input number of children, and let's say the minimum value is going to be 0 and maximum value will be like something like 8, and let's set the default value as 0. Okay, these are going to be enough for column 1, and with the column 2 let's continue with blood pressure like this, and it's going to be Streamlit number input. I will say blood pressure, and let's say like minimum value of 60, maximum value of 200, and value of 120. And for the gender we will say Streamlit select box gender, and it's going to be options, it's going to be label encoder gender classes like this. For diabetic we will say Streamlit select box diabetic, and options are going to be label encoder diabetic classes like this. And at the final for the smoker we will say select box again smoker, and options are going to be label encoder smoker, and it's going to be classes like this. Okay, we have those ready, and after those we are going to say outside of this with column 2 submitted is going to be Streamlit form submit button predict payment, and it's going to be ready like this. And now we are going to pre-process it and predict the payment amount. So we will say if submitted, so if this button is clicked it means that we will say input data is going to be pandas data frame, and we are going to give age like this and gender like this, and we are going to give BMI like this. Next up we are going to give blood pressure like this, and we are going to say diabetic, and it's going to be diabetic like this. And we will say children, it's going to be children, and at the final smoker we will say smoker like this. And after that we are going to do encode the categorical features using saved label encoders. So input data, gender, it's going to be label encoder gender, transform, input data gender, like this. And we are going to continue with the diabetic. Input data diabetic is going to be equal to the label encoder diabetic, the transform, input data diabetic, like this. And next up we will say input data smoker, again smoker, transform, input data smoker, like this. Now we also need to scale the numerical features. So numerical columns are going to be age, BMI, blood pressure, and children. So we are going to take those, and then we are going to say input data numerical columns, and it's going to be equal to the scalar, the transform. We will pass input data, and inside here we are going to give numerical columns like this. And now we are going to predict the payment amount. So prediction is going to be model that we load in here, model.predict, and we are going to give, actually I will type predict, input data, and we are going to take the first result in here in the iteration, and we will say streamlit.success, and let's say like estimated insurance payment amount, and we are going to say like $ prediction, and let's format it like this. And also it's going to be separated with comma. Okay, our app is ready. Now I'm going to save this file, and I'm going to make it run from the terminal, and then I'm going to summarize it after we try our app. Firstly, what I'm going to do is I will say open the terminal and Streamlit run app.py. So the web app is going to be started at this address, localhost 8501. You can just follow this link, go to this address on your browser for reaching to the web app we have in here. I'm going to be re-recording in my browser in a second. Here I am at the address localhost, and we can see that we have our page title, health insurance payment prediction app. We can see the Streamlit right that we added in here. Enter details below to estimate your insurance payment amount, and from the right upper side you can go to settings and change it to wide mode, or you can change the app theme. I'm going to keep it light, and in here we can see that we have an input form with default values that we defined, and at the BMI side we have floats as we defined, and I'm just going to say predict payment with the default options. It says here, I'm just going to quickly change it. I made a typo on there. From here, I think I misspelled the diabetic, like here it is, diabetic. I'm just going to save it, and let's continue on the browser. Now it's fixed. I will just say rerun, and I will say predict payment again. Here we can see that estimated insurance payment amount $27,000 with separated with comma and the 2 decimals. Awesome. So I'm just going to change this number to something like 40, and let's see how our amount is going to be changing. It needs to increase since we increased the risk with BMI. Yeah, here it is. It just increased to 28,000. And now let's just try these options. Like let's just say smoker yes, because we know it was the most relevant option with the increase of the payments. So I just set it as yes, and I will say predict payment. Here we can see that it jumped to the 44,000. Awesome. All the logic is working well, and let's just change this to values like age 20, BMI 20, and smoker no. So we can see the results, like it needs to decrease. Yeah, here it's at 27,000 again. And let's set the number of children like 2. Let's add BMI value of 30, and let's say diabetic yes, and smoker yes, and we are going to see the value of $31,000. And if we just increase this age to 40, we are going to see that we are going to have a similar value, let's say 30, BMI value of 40, let's say gender male, let's change this blood pressure to 140 and number of children to 0 to see our prediction. Here it says $40,000, and let's see when we change smoker to no what is going to be the next value. Here it is $29,000. Okay, our app is working perfectly. Now I'm going to be re-recording on my code editor to summarize the Streamlit web app, and then we can get to the outro. Here we have our prediction app. We don't need terminal anymore, and let's go on this one by one. We do our imports, Streamlit for the web app, pandas numpy for the data manipulation, and joblib for loading the pickle objects that we exported in the Jupyter notebook. And next up we load the scaler, label encoders, and the model we have. We set our UI, then we create a Streamlit form for taking the inputs, then we create a form submit button, and if that button is clicked, we just process the data, we create a data frame from it, we use our label encoders for transforming the data that came, and in here we just scale the numerical features and we get a prediction from our model, and after that we display it in our Streamlit app. That was it for this video. Thanks for watching. Let's get to the outro. Thanks for watching this data science project. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Also, I have a playlist named Data Science Projects where I have more than 50 videos just like this one. You can reach that playlist from the cards of this video or from the links in the description. Have a great day.